Okay, so in this video we're going to be going over a few past paper questions regarding the discriminant. In the previous video we discussed some rules regarding the discriminant and concluded with some key notes, which were these. And we're going to be using these keynotes for these past paper questions. Alright, now let's go over the questions. This is the first one. The line y is equals to x upon k plus k, where k is a constant, is a tangent to the curve 4y is equals to x squared at the point P. So at the tangent to the curve means it meets at one point. This line meets at one point to the curve, so they intersect at one point only. And when a line is tangent to the curve means it has only one real root, and that is when the discriminant is equal to 0. Alright, now so we know that the discriminant is equal to 0, and we're going to be calculating it by equating the two y's to each other. So the first y is going to be like this, and this is going to be this. We're going to be substituting equation 1 into equation 2. And we are reaching a quadratic formula, a quadratic equation. So this is our equation, and we know that the discriminant is equal to 0. So we're gonna be first labeling what we have. A is equals to k, b is equals to minus 4, and c is equals to minus 4 k square. So this is going to be squared, this is going to remain k, this minus 4k square is going to be equal to 0. This gives us 16 plus 16k cube. K is going to be minus 1. A bit direct, but we have much to solve, so I'll be keeping it short. So this is k. We have gotten k, and now we need to find the coordinates of P. Okay, so since we know that these two equations are gonna be equated to each other as these two as a line and the curve meet at one point, so it's gonna be y is equals to y. But this time we're gonna be doing y is equals to y with the value of k in mind. So the equation of the line was x upon k plus k. Now it's gonna be x upon minus 1 plus minus 1, which gives us y is equals to minus x minus 1. This is the new equation, and now we're going to be equating this to the curve equation, x squared upon 4. So minus x minus 1 is now is equals to x squared upon 4. And this is our quadratic equation. Time to factorize this. Oops. X squared plus 2x plus 2 by the middle term break. and we have two real and equal roots here, x plus 2 and x plus 2. We're going to be taking any one. We get x equals to minus 2. So this is point P. This is the x coordinate of the point P. To find the y coordinate, we are going to be substituting the value of x into any of these equations. I'll take this one. This is this one. So P has the coordinates minus 2 and 1. Alright, pretty easy. Okay, now let's move on to the second question. The equation of the curve is y is equals to x squared minus 3x plus 4. Show that the whole of the curve lies above the x-axis. Wait, let me check if it's recording. Okay, it's recording. So this is the curve equation, and we need to show that this curve lies above the x-axis, meaning that it doesn't intersect with the x-axis, and hence there are no x-intercepts, hence there are no real roots. So when there are no real roots, we know that the discriminant is less than 0, as written here. Less than 0. No real solution. And the line and curve don't meet. So the curve and the x-axis don't meet. If I were to visualize this, then I'd have something like this. It's not meeting, and that the whole of the curve is above the x-axis. And another proof of this is that we have a minimum point over here, meaning that the parabola is upwards. It's not a smiley face. It is a smiley face, it's not a sad face. That's another proof, but we're going to be using the proof that the discriminant is less than 0. So we have the equation here, x squared minus 3x plus 4. And yeah, so let's figure out the discriminant. B squared minus 4ac less than 0. A is equals to 1, B is equals to minus 3, C is equals to 4. So minus 3 squared minus 4, 1 and 4. We get 9 minus 16, which gives us minus 7. And here it's proved that the discriminant is less than 0, as we are getting minus 7, which is indeed less than 0. So this is our proof. Okay, we are done with the proof. Now let's move on to question number 2. Find the set of values of x. In other words, we can consider this as a range of values which is going to be defined by an inequality, for which x squared minus 3x plus 4, which is this equation of the curve, is a decreasing function of x. So we did go over the fact that what were decreasing functions and increasing functions, but for explanation's sake, I'm just going to be covering this up here. So this is our curve, alright, and this is a curve where the coefficient of the x squared is positive, and this is where it's negative. So here this is a stationary point, and here's where things start to get complicated. So from this point, wait, let me use a different color. So from this point to this point, we say that the curve has we say that the curve has a decreasing function of x, alright, because the gradient is decreasing. And from this point to this point, we say that the curve has an increasing function of x, since the gradient is increasing, and the opposite goes for this. So here it's increasing and here it's decreasing. So in this case, the coefficient of the x square is positive 1. So we're going to be following this curve over here, and according to this curve, we know that this equation here has a decreasing function of x up until this point over here, and this point is called the vertex, the stationary point of the curve. So if we get this value, then we can easily deduce the set of values of x for which this equation has a decreasing function of x. So let's do this. So we're going to be figuring out the vertex for this equation. We had two methods for that, the completing the square method and the shortcut. I'm going to be using the shortcut since there is no requirement. And x equals to minus b upon 2a gives us the x coordinate of the vertex, and this gives me 3 upon 2. This is the x coordinate of the vertex. To find the y coordinate, I'll be substituting this value. Oh wait, I don't need the y coordinate, I just needed the set of values for x. So with that, I can say that whenever x is less than 3 upon 2, that is when this curve is gonna have a decreasing gradient, because actually this curve doesn't just have an asymptote over here, it actually goes like this. Yeah, something like this. So this curve is just gonna keep on going and going and going till infinity. So that's why we say that when x is less than this value, it's gonna have a decreasing function of x. So this was it for question question part 2. Let's move on to the next part. The equation of a line is this, where k is a constant. In the case where k is equal to 6, find the coordinates of the points of intersection of the line and the curve. Okay, so y plus 2x equals to 6 is the equation of the line, and this is intersecting with the curve, which was y is equals to x squared minus 3x plus 4. So we're just going to be equating these two simply. Minus 2x plus 6 is equals to x squared minus 3x plus 4, and solve it till we get a quadratic equation. Now I'm going to be using the numerator break. Here I have two factors. So x is going to be equal to minus 1 and x is going to be equal to 2. These are the x coordinates of the 2 points of intersection. Let me okay, so taking y plus 2x equals to 6, I'll be inputting when x is equal to minus 1. Okay, so these are the 2 points of intersection. When we found out the x values, we substituted them into any of the equations and got the y values, and hence got the coordinates of the point of intersection of the line and the curve. With this done, now we have our part 4, which says to find the value of k for which the line is a tangent to the curve, meaning when the discriminant is equal to 0. Let me just write this down. Discriminant for c is equal to 0. Okay, so in the previous part we were considering k as 6, but in this part we are going to be considering k as an unknown. So we have y plus 2x equals to k, and y is equals to x squared minus 3x plus 4. And here we're going to be equating the two once again. So with this equation, we're going to be now finding the discriminant. b squared minus 4ac is equal to 0. This is one equation. Here we have a as 1, b is equals to minus 1, and c is equals to 4 minus k. Substituting these values would give us minus 1 square minus 4 1 and 4 minus k. 1 minus 16 plus 4k is equal to 0. Minus 15 plus 4k is equal to 0, and k is equals to 15 upon 4, which in other words would give us 3.75. Right, easy. With this done, let's move on to the last question. A straight line has equation this. Okay, wait. This is the equation of straight line. This is the equation of the curve. Show that the x coordinates of any points of intersection of the line and the curve are given by this equation. Okay, and this is only going to be shown when we equate the two y's together, because they want us to find the points of intersection, and we have already went over this. So let's do this. Y is equals to minus 2x plus k. Y is equals to 2 upon x minus 3. When you equate the two, you're gonna get something like this, hopefully. Take x minus 3 to that side to expand it. I'm going to be moving everything to the left hand side, as the question demands for a positive coefficient of x square. So 2x square minus kx minus 6x plus 3k plus 2 is equal to 0. 2x square, we're going to be taking minus as a common here, which leaves us with 6 plus kx, and then the constants 3k plus 2. And I think we're getting the same equation. And yes, we are. Next part says find the two values of k for which the line is a tangent to the curve. Once again, b square minus 4ac is equal to 0. So let's do this. We're going to be using the same equation that we have over here now. So here we have a is equal to 2, b is equal to minus 6 plus k, and c is equal to 3k plus 2. Substitute these values to find the value of k, the values of k. Minus 6 plus k, minus 6 minus k squared minus 4, 3k plus 2, 36 minus 2 minus 6 k plus k square minus 24k minus 16. Yeah, so this gives us something like this. This is our quadratic equation. Let's factorize this. 10 to the 20 So minus 10k minus 2k plus 20 k minus 10 minus 2 k minus 10. We have two values of k over here. This gives us k is equal to 2 and k is equal to 10. These are the two values of k. The two tangents given by the values of k found in part 2 touch the curve at points a and b. Find the coordinates of a and b and the equation of the line AB. Okay. So here we have two equations now. Since we have two values of k, k is either equals to 10 or 2, and the equation of the line is y is equals to minus 2x plus k. And this is a 6-mark question, so yeah, it's a pretty long day. So find the coordinates of a and b and the equation of the line AB. So if I were to visualize this, then what's happening is that this is the curve. Oops. This is the curve, and there are two tangents here. This is point A, and this is point B. And when we get the coordinates of these 2 points, we can easily find the equation of the line using y minus y1 is equals to mx minus x1. So how are we going to do this? Let's figure this out. So here we know that these are going to be two equations. Y is equals to minus 2x plus 2. Okay, let's solve for k is equals to 2 first. So simplifying this would give me and factorizing this would also give me this. We have once again two distinct real roots over here. Sorry, similar equal real roots. This gives us x equals to 2. And to find the y coordinate of this, we're just going to be using this one. Y is equals to minus 2x plus 2. So y is equals to minus 2x plus 2 gives us minus 2. And this is 1 point. Now for the other coordinate. Y is equals to minus 2x plus 10. Let's solve this. Okay. easy factorization. Two equal real roots. X is equal to 4, and putting this in this equation, I believe it. So minus 8 plus 2 is minus 6, and this is going to be our coordinate. Alright, so these are the two coordinates, and now using y minus y1 is equals to m x minus x1, we can figure out the equation of the line. But to do this we need m. So what is m? It's a gradient of a slope, and here we're going to be using this as the 2. Oops, this is the 2 and this is the 1. So y2 minus y1 upon x2 minus x1, so minus 4.2 gives us minus 2. And using this, we can figure out the equation of the line. And this is the equation of the line of AB. Okay, so since we were using different equations for both the workings, here is going to be 2 and here is going to be 10. So this was a previous mistake, but now that that's resolved, our new coordinate is 4 and 2 and 2 and minus 2. So these are going to be changed as well. We're going to get a new m. So y2 minus y1 upon x2 minus x1, this gives us 2. 4.2 is 2, and here y minus 2 is equals to 2x minus 4, to x minus 8, then this is the equation of the line AB. So with this we are done with the past papers for the discriminant, and now we're going to be focusing on inequalities in the future videos.